Dear and beloved students, welcome to our class, Chapter 3, Temperature. Before I start the class, as usual, I would like to tell a small story with some moral value. A boy put his hand into a pitcher full of chocolates. He grasped as many as he could possibly hold. But when he tried to pull out his hand, he was prevented from doing so by the neck of the pitcher. Unwilling to lose his chocolates on one side, yet unable to draw his hand, the boy was burst into tears and bitterly lamented his disappointment. A bystander said to him, "Be satisfied with half the quantity. You must have been very and absolutely happy." So the moral is, do not attempt too much at once. Good. So now let's go into the class. In this class, we are going to study and understand what is the temperature, what is the heat definitions, importance of air temperature on croplands, basic laws of temperature. Okay. Now, temperature is defined as measure of speed per molecule of all the molecules of a body, whereas the heat is the energy arising from random motion of all the molecules of a body. The temperature of a body is the condition which determines its ability to transfer heat. Transfer heat means energy to other bodies. The temperature of a body is the condition only which determines its ability, to transfer heat energy to other bodies or to receive heat from them, vice versa also. In a system of two bodies, the one which loses heat to the other is said to be at a higher temperature. In a system of two bodies, the one which loses heat, which loses energy to the other is said to be at a higher temperature. That means the heat energy moves from higher to lower because the energy always moves from higher to lower. Good. Now, what is the importance of air temperature on croplands? Please note that the chapter of temperature is broadly divided into two. One is air temperature, the other one is the soil temperature. In the first part of our temperature, we are going to discuss only air temperature. That's it. The second part, soil temperature. Both air and soil temperatures are entirely different with reference to agriculture. That means crops, animals, whatnot. That's what. So, the first part of our temperature is air temperature. So far what we understood, the definitions of temperature and heat. Temperature is defined as measure of speed per molecule of all the molecules of a body, whereas the heat is the energy arising from random motion of the all molecules of a body. That means heat measures total molecular energy. Temperature measures average energy of individual molecules. temperature is that characteristic of a body which determines the direction of heat flow by conduction. By conduction. By conduction. This is what? Okay. Heat measures molecular activity, temperatures measure average energy. So, these are the basic differences between temperature and heat. Temperature is measured by degree centigrade, degrees Fahrenheit, degrees Kelvin. Energy is measured by solar energy. First, I told in the first classes, ergs, joules, watts per meter square. So, that's what. So, energy, they are the heat is the energy units are there. Now, the next part of our class is importance of air temperature on crop plants. Importance of air temperature. As I said a minute back, the temperature chapter is divided into two major groups, air temperature and soil temperature. Now we are discussing air temperature. Now, what is the importance of air temperature on crop plants? Air temperature influences distribution of crop plants and vegetation. The growth and development of crop plants are chiefly influenced by air temperature. Air temperature affects leaf production, expansion and flowering. Physical and chemical processes within the plants are governed by air temperature. The diffusion rate of gases and liquids changes with temperature. What exactly does it mean? Carbon dioxide entering, water molecules going out, some gases entering, some gases leaving. All these are controlled by air temperature. The solubility of different substances is dependent on temperature. In the crop plant, the solubility of different substances is dependent on temperature. The biochemical reactions in crops are influenced by air temperature. Equilibrium of various systems and compounds is a function of air temperature. Temperature also affects the stability of enzymatic systems in the plants. So, these are the points which indicate the importance of air temperature on crop plants. Fourth time I am telling, we are discussing temperature broken into two. This is the first one, air temperature. After knowing the definitions of temperature and heat, we tried to understand the importance of air temperature on crop plants. Now, there are several laws of temperature. In the previous chapter, that is chapter 2, solar radiation, some basic laws of solar radiation we tried to understand. The basic laws of solar radiation in that class what we studied were Planck's law, Kirchhoff's law, Stefan Boltzmann's law, Wien's displacement law. These were the basic solar radiation laws. In the solar radiation chapter we tried to understand. Similarly, to understand both air temperature and soil temperature and their effects, practical point of view, some basic laws are most essential for understanding the influence of both air temperature and soil temperature on the crop plants. So, we are discussing just 5 basic laws. 5 basic laws. These are Boyles Law, Charles Law, Universal Gas Constant, Van 't Hoff's rule, it is also known as the Q10 rule. And among the thermodynamics, we just try to understand the first law of thermodynamics. Now, once again, the way in which we tried to understand the basic laws of solar radiation, like Planck's law, Kirchhoff's law, Stefan Boltzmann law, Wien's displacement law. Here we are trying to understand some basic laws, just 5 laws, very interesting laws. You will be very happy after this explanation is over from my side why we are studying these laws. Number 1 is Boyles Law. For a gas, temperature remaining constant, the product of pressure and volume is also constant. For a gas, temperature remaining constant, the product of pressure and volume is also constant. That is, when volume increases, pressure decreases. Wonderful law, wonderful law. Boyle's law. Okay. What it says? The product of pressure and volume will also be constant when temperature remains constant for a gas. That means when volume increases, the pressure decreases. Now, Charles' law. The volume of a given mass of gas is directly proportional. The volume of a given mass of gas is directly proportional to the absolute temperature at constant pressure. Again, wonderful law, Charles' law. Innumerable experiments were conducted. Several uses of Charles' law, Boyle's law, we are observing in day-to-day life. Once again, Charles' law is that the volume of a given mass of gas is directly proportional to the absolute temperature at constant pressure. This is at constant pressure is very important here in the Charles' law. So then, let us go to simple explanation of universal gas constant. The constant linking 3 pressure, volume and absolute temperature of an ideal gas is equivalent to 8.3143 joules per Kelvin per mole or 1.9858 calories per degree Celsius per mole. That's it. Simple. A constant linking pressure, volume and absolute temperature is universal gas constant. These 3 also we discussed in Boyle's law and Charles' law. Now, what is Van 't Hoff rule? It's also known as Q10 rule. Very interesting for crop plants. The rate of response of a process in crop plants. The rate of response of a process. The rate of response of a process in crop plant is often doubled or more for each increase of 10 degrees centigrade of temperature within certain limits. What a great rule. What a great Q10 rule. The rate of response of a process in crop plant is often doubled or more for each increase of 10 degrees centigrade of temperature within certain limits. That means the crop plant's response for 10 degrees centigrade and the crop response for 20 degrees centigrade is almost double the response you get. From 20 to 30 degrees centigrade when the temperature has increased, okay, it is again doubled. So, where it was in 10, by 30 degrees centigrade, the response rate of a particular process in crop plants is almost doubled, of course within certain limits. Maybe less than 10, maybe more than 50, very harmful. Now, the last law of the basic laws of temperature is the first law of thermodynamics. It's a wonderful law. Again, like Boyle's law, Charles' law, universal gas constant, Van Hoff's rule or Q10 rule. The first law of thermodynamics is also a wonderful law. The law of conservation of energy is the first law of thermodynamics. The law of conservation of energy is the first law of thermodynamics. Now, what is that? Law of conservation. What is law? What is conservation? What is first law of thermodynamics? The law states that in a system of constant mass is constant, energy can neither be created nor destroyed. In a system of constant mass, energy can be neither be created nor destroyed. Classical example is mechanical equivalent of heat is the special case of this law. Just for example, if you just rub your both hands, the mechanical work you are doing is equivalent to heat produced. This is the special case of law. Now, with this, the basics 1 of temperature, particularly air temperature we are discussing. In this class, what we tried to understand are definitions of air and soil temperature and heat. The measure of speed per molecule of all the molecules of the body is temperature. The energy arising from random motion of all the molecules of the body is heat. Importance of air temperature on crop plants. It ranges from air temperature influences the distribution of crop plants. From there to the temperature of air affects the stability of enzymatic system in crop plants. Then we tried to understand in this class air temperature, basic laws of temperature, Boyles Law, Charles Law, universal gas constant, Van Hoff's rule, the first law of thermodynamics. Thanking you. We meet in our next class.